Hello friends. Here's a question worth asking right now. If privacy services are booming, why are millions of people still handing their traffic to a company they do not control? The global VPN market is projected to hit $70.46 billion in 2026, according to Mordor Intelligence, driven by growing censorship, age verification laws that demand personal data just to browse the web, and a permanent shift to remote work. And here's the thing. Linux runs nearly 78% of all web-facing servers, which makes it the natural home for a self-hosted VPN. In this video, you will build a real WireGuard server on Ubuntu 26.04 LTS, from a blank machine to a working encrypted tunnel, step by step. Let's start by understanding exactly why WireGuard has become the default choice in 2026. Alright, let's talk about why WireGuard has replaced OpenVPN as the go-to choice for new deployments. OpenVPN has been around since 2001 and runs in user space, meaning every packet crosses the boundary between the kernel and your application layer twice. That overhead adds up. OpenVPN's codebase also exceeds 600,000 lines of code, which is a lot of surface area to audit for bugs. WireGuard takes the opposite approach. It lives inside the Linux kernel and clocks in at roughly 4,000 lines of code. That small size means one developer can read the whole thing in an afternoon. On a 1 gigabit connection, benchmarks show WireGuard reaching 940 to 960 megabits per second, while using just 8 to 15% of CPU. OpenVPN uses considerably more CPU and delivers significantly lower throughput on the same hardware. That gap is why WireGuard is now the 2026 default. Let me show you exactly how to get it running. Now look at this. Installing WireGuard on Ubuntu 26.04 LTS is almost embarrassingly simple. The reason is that the WireGuard module has been built directly into the mainline Linux kernel since version 5.6. Ubuntu 26.04 ships kernel 7.0.0, so the module is already there the moment your server boots. You do not need DKMS, you do not need third-party repositories, you do not need to compile anything. Setup guides tested on Ubuntu 26.04 in spring 2026 confirm this. Just run sudo apt update, then sudo apt install WireGuard. That single command pulls in the WireGuard tools package, which gives you the WG and WG quick utilities. To confirm the module loaded, run mod info WireGuard. You will see the version and license printed back instantly. That is your whole install. Now we need keys, and here is where the interesting part begins. Here is the interesting part. WireGuard uses public key cryptography, so there are no certificates, no certificate authorities, and no renewal dates to track. Every peer, meaning every device, is simply identified by a public key. To generate the server key pair, run wg genkey, pipe it through T to save the private key, then pipe it again through wg pubkey to derive the public key. Then lock down the private key file with chmod 600 so only root can read it. Next, create the file at /etc/wireguard/wg0 conference. The interface block sets the VPN address 10.0.0.1 on the /24 subnet, the listen port 51820, and your private key. The peer block holds your client's public key and the allowed IPs field, which tells WireGuard which source address to accept from that peer. This config is the whole server identity. Next up, we make traffic actually flow. Alright, the config file alone is not enough. 3 things must happen for traffic to actually flow through the tunnel. First, you have to tell the Linux kernel to forward packets between interfaces, because by default it does not. Write netipv4.ip_forward equals 1 into the sysctl config file and apply it with sudo sysctl system. Second, you need NAT masquerading, which rewrites the source address on packets leaving your server so the internet sees your server's public IP, not the client's private tunnel address. Add post-up and post-down IP tables rules directly in WG0 conference. Post-up fires when the interface comes up and inserts the rules. Post-down removes them cleanly on shutdown. Third, open UDP port 51820 on your firewall. WireGuard runs exclusively over UDP. All 3 steps together, forwarding, NAT, open port, are what transform a config file into a working tunnel. Now let's verify it and lock it down. Now look at this. Bring up the interface with wg quick, up wg0, then run sudo wg show. You will see the server's public key, the listen port, and, once a peer connects, a recent handshake timestamp and transfer counters. A handshake within the last few minutes means the tunnel is alive. To make the server survive a reboot, enable the systemd service with systemctl enable, then now, wg quick at wg0. That one command handles auto start on every boot. For hardening, Add a kill switch by blocking all non-tunnel forwarded traffic and IP tables so clients cannot leak if the tunnel drops. And because WireGuard's codebase is only around 4,000 lines, keeping it patched is straightforward. Run apt upgrade regularly. This is exactly why Proton VPN, in its spring 2026 roadmap, rebuilt its entire client around a new WireGuard codebase. Small, fast, auditable. That is your server, your keys, your tunnel, fully under your control.